Hi friends, welcome to my YouTube channel. This is first part of lecture number 23, and in this lecture we will study circuit and waveforms of one phase half wave controlled rectifier with RE load. So this is the circuit diagram of rectifier. In this load is RE type and we get output voltage V0 across this load. This load is connected in series with this thyristor and this whole circuit is supplied with voltage source Vs. Here Vs is sinusoidal voltage source, that is equals to Vm sin omega t, and this is the waveform of sinusoidal voltage source. So we will understand the operation of this circuit in 5 angular slots. First we will study the operation from 0 to theta, then from theta to alpha, then from alpha to pi minus theta, then pi minus theta to pi, and then from pi to 2 pi. Before starting the circuit operation, I want to tell you two important things. First is the waveform of EMF E and waveform of source voltage Vs intersect at this point, and this point is theta. So what is theta? At this point of intersection, EMF E is equals to the sinusoidal voltage source. So we can write E is equals to Vm sin theta, where Vm sin theta is value of source voltage Vs at angle theta. So from this equation we can get the value of theta, and theta will be equals to sine inverse E by Vm. Now second point is before theta, from 0 to theta, what happens? This EMF E lies over the waveform of this Vs, and if we apply KVL in this loop, then we get thyristor voltage Vt is equals to Vs minus E. If Vs is less than E, then in that case we get thyristor voltage negative. So when thyristor voltage is negative before theta, in that case if we fire this thyristor, then it will not get turned on because it is reverse bias before theta. That's why we have to fire the thyristor after theta. That's why we can conclude from this alpha is always greater than theta. Now after knowing this much concept, we will start the circuit operation from 0 to theta. From 0 to theta, thyristor voltage is given as Vs minus E. Okay, because thyristor is initially turned off. So Vt is equals to Vs minus E, and we know that from 0 to theta, source voltage is less than EMF E. So when source voltage is less than EMF E, then we get negative or reverse voltage across the thyristor, or we can say that anode to cathode voltage of thyristor is negative. So we get Vs less than E, so thyristor is in reverse blocking mode. And when thyristor is in reverse blocking mode, then thyristor acts as open circuit. So from 0 to theta, thyristor acts as open circuit. When thyristor is open circuit, then current in this loop is equals to 0. Okay, so that's why we get I0 is equals to 0. And what is V0? When I0 is equals to 0, we get V0 is also V0 equals to E. Why we get V0 equals to E? Because V0 is equals to I0R plus E. I0 is equals to 0, that's why we get I0R is equals to 0, and simply we get V0 is equals to E. Okay, and what is output power P0? Here we can clearly see that I0 is equals to 0 and V0 is greater than 0. That's why P0, that is product of V0 into I0, we will get it 0. That's why P0 is equals to 0 from 0 to theta. Now see the circuit operation from theta to alpha. From theta to alpha, here in this waveform we can clearly see that from theta to alpha, the source voltage Vs waveform lies above this EMF E, or we can say that Vs is greater than E. Okay, Vs is greater than E, so we can say that thyristor is forward bias. But thyristor is not triggered yet, because from theta to alpha thyristor is not triggered. That's why thyristor continue to be in off state. So when forward voltage is applied across thyristor and thyristor is in off state, then we can say that thyristor is in forward blocking mode. So in forward blocking mode, thyristor continue to act as open circuit. When thyristor act as open circuit, then current in this loop is equals to 0. That's why we get I naught is equals to 0. And what is output voltage V naught? If I naught is equals to 0, then drop across this resistance is equals to 0, and simply we get V naught is equals to E. Now what is thyristor voltage? Again, if we apply KVL in this loop, thyristor is open circuited, and that's why we get Vt is equals to Vs minus E. And what is output power P naught? So to get the output power P naught, what we do? We simply multiply V naught into I naught, and here we can see that from theta to alpha, V naught is greater than 0, I naught is equals to 0. That's why we get P naught is equals to 0. Now see, when thyristor is turned off from 0 to alpha, okay, from 0 to alpha, thyristor continue to act as open circuit. So in that case, voltage across thyristor is given by Vs minus E. Okay, so this is the waveform of Vs minus E. For this waveform, at omega t is equals to 0, we know that Vs is equals to 0. That's why we get Vt is equals to E. Okay, here we get Vt is equals to minus E, because if this Vs is equals to 0 at omega t is equals to 0, then we get Vt is equals to minus E. Now what is this point? That is value of thyristor voltage as at omega t is equals to alpha. At omega t is equals to alpha, value of this sinusoidal voltage waveform is equals to Vm sin alpha. Okay, so that's why this point at alpha is given as Vm sin alpha. Okay, and minus E. So Vs is equals to Vm sin alpha and minus E. It means we get Vm sin alpha minus E. So this point at omega t equals to alpha, thyristor voltage is given as Vm sin alpha minus E. Okay, here it is again thyristor voltage. Now move to next slide. Now we will see the operation from alpha to pi minus theta. From alpha to pi minus theta, we see that this gate pulse is applied. It means thyristor is fired at omega t is equals to alpha. And here from alpha to pi minus theta, we can clearly see that waveform of sinusoidal voltage source lies above this red dotted waveform of EMF E. It means we can say that Vs is already greater than E and thyristor is triggered. That means gate current is applied to the gate terminal of thyristor. So both the condition required to turn on the thyristor are satisfied. That's why thyristor starts conducting and thyristor goes in forward conducting mode. So during forward conducting mode, thyristor acts as short circuit. When this thyristor gets short circuited, then current I naught starts flowing in the circuit. And what we get output voltage? We get output voltage is equals to Vs. Okay. So when thyristor starts conducting, the source voltage will appear across the thyristor. Source voltage appear across the load. Okay, and thyristor act as short circuit, and during short circuit drop across thyristor is equals to 0. That's why we get Vt is equals to 0. Now what is current I naught? I naught is simply given by I naught is equals to Vs minus E by R. Okay, by simply applying KVL and getting the value of I naught. Okay, so now we will see the operation from pi minus theta to pi. from pi minus theta to pi, what happens? Here in this waveform we can clearly see that after pi minus theta, Vs again becomes less than EMF E, or we can say that Vs is less than E because waveform of source voltage lies below this red dotted line of EMF E. That's why Vs is less than E, and at pi minus theta this current becomes 0. So when current becomes 0 and Vs is less than E, it means thyristor voltage, that is equals to Vs minus E, becomes negative. So there are two conditions. First is thyristor voltage becomes negative and current becomes 0. So due to this, thyristor goes into reverse blocking mode, and during reverse blocking mode thyristor acts as open circuit. When thyristor get open circuited, then current through thyristor becomes 0, or we can say that I naught becomes 0, and when I naught becomes 0 we get V naught is equals to E thyristor voltage, again we get by applying KVL in this loop. And what is output power P naught? Here when I naught is equals to 0 and V naught is greater than 0, then P naught is equals to V naught into I naught, we get P naught is equals to 0. Now see the operation from pi to 2 pi. From pi to 2 pi, Vs continue to be less than EMF E. When Vs is less than E and thyristor is already in off state, then thyristor will continue its off state from pi to 2 pi. So thyristor will remain turn off from pi minus theta to 2 pi. Okay, so till this period thyristor will remain turn off. Okay, now what is output voltage? So when thyristor is off, then it acts as open circuited, we get no current across output and we get V naught is equals to E, and voltage across thyristor again during off state by applying KVL, we get thyristor voltage Vt is equals to Vs minus E. So see, this is thyristor Vt and this is correct, this is not Vt, this is Vt. Okay, and what is output power P naught? Again we get P naught is equals to 0. So here in this circuit we can clearly see that we get thyristor voltage that is equals to Vs minus E from pi minus theta to 2 pi plus alpha, because this thyristor will remain turn off till we again fire this thyristor. That's why we get Vt is equals to Vs minus E from pi minus theta to 2 pi plus alpha. Okay, so this waveform will look like this. Now if I ask you what is the maximum value of this waveform, so this maximum value of waveform will occur at angle 3 pi by 2. So suppose this is 3 pi by 2. Okay, so maximum value reverse voltage across thyristor occur at 3 pi by 2. And what is the value of this reverse voltage? We know that at omega t is equals to 3 pi by 2, Vs will be equals to minus Vm. Okay, so when Vs is equals to minus Vm, then we get thyristor voltage is equals to minus in bracket Vm plus E. That's why maximum reverse voltage across thyristor is equals to minus in bracket Vm plus E. Now what is this point? Okay, at 2 pi plus alpha, the sinusoidal voltage source Vs is equals to Vm sin alpha, and if we subtract E from this, then we get Vm sin alpha minus E. So this point will be equals to Vm sin alpha minus E. So this is all about the circuit operation of control rectifier with RE load. I hope you understand the concept. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.